Hello viewers and welcome to a new STM32 World video. In this video we are going to talk about displays and this is going to be an interesting journey as usual. If you like this video, please like and subscribe down below. It is absolutely essential for a small channel like this in order for it to grow. Some years ago, while buying something on AliExpress, I don't remember what it was, I came across these, let me see, I need to make myself small, these displays on AliExpress, and they're quite interesting, and there is a number of different sizes and formats of them, but typically they are, the most common one I think is the 1.3 inch square display, and they are insanely high resolution. They are 240 pixels times 240 pixels on 1.3 inches or less, because it's only 1 inch that way, or less than 1 inch. So they are fairly high resolution and very bright colors, and so they are cool little displays, and I thought I would make a video on these. Now, what happened back then? I probably bought my first couple of boards. I bought them like this, where the display is mounted on a PCB and there is a breakout. But the displays are also available, we have it here, as a standalone display, and they are typically just a very flat display, and then they have like a flat flex connector. And the way you would typically mount them is that you would put the display on one side of a board and then wrap them around the connector to the other side of a board, either through a slot or around the edge of the PCB. And this is in fact exactly what I did. I designed my own, I call it magic key, and that was simply because I had no idea at the time what I wanted to do with it, but it was intended to be like this, where you have the display and then four buttons, and then the electronics on the flip side of the board. And I did in fact produce these. I can show it here. Why did it do that? So there is the display, and there's one of the boards, and mounted the display will go like that, and then the flat flex will wrap around on the other side of the board, and where's that? And here you can see it. Have to look. Here you can see it before it is soldered. The flat flex is sticking out there, and it simply wraps around and matches up with these pads on the board, and they can simply be soldered on. It is actually easier to solder than you could imagine at first. It is a matter of having lots of flux, and then you just basically hold this connector in place so it's precisely aligned to these, and then you just run some solder over them, and everything just lines up and connects very easily. So today I'm going to use this board with one of these displays to show how it works. This board, just to make clear, it is based on an STM32 L432 KC, I think it's called. B is a small one and C is a big one. So yes, that's what we're going to do today. Now, addressing 240 times 240 pixels, that is an enormous amount of LEDs that needs to be RGB LEDs, no less, that needs to be controlled precisely. And I mean, that is almost impossible to do from an STM32 without some kind of driver IC. Fortunately, these displays comes with a built-in driver IC, and that driver IC is a chip called ST7789. So these displays are typically identified by that driver chip, the ST7789, and that ST ST7789. I think the maximum is 240, but it can go up to 320 lines. So I've seen displays for 320 times 240. In our case, it's 240 times 240, and I have also seen smaller ones that are not square, so they're 240 one way, and maybe, I don't know, 120 on the other way. I haven't really used any of those. So the ST7789 is actually a very complicated little IC, but fortunately there is actually documentation available. The datasheet is available from a company called Sitronics, and they do release this. It's confidential, so maybe they don't release it. Maybe it was just leaked on the internet. I do not know. But it is fairly well documented how to address this, how to work with this chip. And if you look at the documentation just here on AliExpress for this particular display, it will go through, it will show you the size, it will show you the physical dimension of this, and more importantly, it will actually down here show the connectors for this particular device. And you can see there's actually only 12 pins that needs to be connected. There's ground, there is LED anode, LED cathode, that is the backlight. So it is a simple LED. There's probably more than one, but it is a simple LED that works so if you can control this, you can control the backlight. Then it has the power supply, and it's got more ground pins. It's got a DC signal, so-called DC signal, that switches between data and commands for this in 4-line serial interface. I don't know why they call it a 4-line serial interface. You got a chip select, and the interesting part down here is that they actually name it wrong, because SCL and SDA is typically indicating that this is an I2C or I2C bus. But it isn't, in fact. It is half a SPI bus, or a one-directional SPI bus. So the SDA signals should actually be named MOSI, Master Out, Slave In. Well, it does say SPI interface here. Yeah, and then they call the other one SCL, which is typically what the clock is called on I2C, but on SPI it's typically SCK. So it also have a reset pin where you can reset the display, and well, more ground. So that is pretty much how these displays are. So the IC, I don't know if it's actually stuck on the flip side of this, or it is under the display, or how these physically are put together. I never broke one apart, but before we are diving into the code, let me make myself bigger. These are the boards, and you can see this particular board. I actually have a debug header up here for the programming, for the development, but normally it can actually be flashed using DFU through the USB port. So the debug is not really necessary except for development. So this is the boards, and as you can see, they are the thickest part is actually the USB connector. I don't know if you can see that there, or maybe at the end like that. Don't know. So yeah, it's a cool little device. So let's dive into some code. Now, using the ST7789 display, there is a lot of little details and a lot of initialization, and I am not going to go through every little detail in this video, merely pointing out a library. And I will see if I go away here. I have made a repository, which I of course will link down below, called STM32 ST7789. Now, the content of this This library comes from different sources, but you can see up here I originally forked it from a guy called Floyd Fish, or Postry called Floyd Fish, and he mentioned down here that he took some stuff from an Arduino library and from another library, 7735 library, and there's some contributors that have contributed other details. So it is a bit of a mess. The license is actually GNU DPL3 license, which is annoying, but it's okay. I'm not going to change that. But the source code is actually interesting because there's absolutely no references in the source code who wrote it or where it came from. So the license situation for this particular library is a little bit dodgy, to say the least. Anyway, what I have done is I have created a project over here using the STM32 L432, but it is just using the library which is in a separate folder. Now, first of all, let's look at the MCU setup in CubeMX. Now, everything is just getting the MCU up and running and having serial output and all that, but the interesting part is to set up an SPI port, and I'm using SPI 3. That's dictated by my hardware, because in my case I'm actually using the other SPI on the actual hardware. I'm using the other SPI down here. I'm using that for a flash chip. So it has to sit on this, and you can see up here compared to the datasheet before, we have all the signals up here. We have the backlight switch, we have the clock, we have the chip select, we have the MOSI, as I mentioned, we have the data command toggle, and we have a reset pin, and all these are up here. I have also, this is configured as fast as it can possibly run, which is 40 megahertz, megabit per second, and I have also configured a DMA stream, which is just one way. It's a memory to peripheral, where I can do the SPI transmit with the DMA to speed it up. So that is the configuration. Now, in using it in an application is really quite simple. You include the ST7789 and the funds header, and then the funds header is not really necessary for what I'm doing here actually. And then it is a simple matter of initializing the library, and the display is running, and that is all. Now, one of the things I changed in the source code is of the library that I forked is that in the header file here, it contained all the configuration up in the top. Now, what I have done is I have broken that out into a separate header file so that you don't have to change the source code of the library in order to use it. You simply set these configuration in a separate file called ST7789 config.h, and first thing to configure in here is which SPI port are we using? Are we using DMA? Yes or not? No. And which signals are we actually using for the different things, and the resolution and the rotation. Depending on how these displays are physically mounted, you might need to rotate it. Apparently, I am not rotating it for this one, so it is meant to have this connector up, but you could imagine in a hardware where you mounted it sideways, you would have to rotate in one of the directions to make it look upside down, and that can all be configured in this config file. But apart from that, the source code, there is not much to say about it. In the header file, depending on, you can see you have a resolution 135 times 240. And 170 times 320 are also available. So depending on this, we are using this one, and there is apparently some shift values that needs to be defined, which depend on that configuration and is used inside the library itself. Down here we also have some color definitions. Notice that this one is using RGB 565 format, not full 888 bit, but only 5 bits for the red and 6-bit for the green and 5-bit for the blue RGB values. It means that you can put the values in 16-bit rather than 24-bit. And that is just a more compact way of... apparently, I'm no expert in colors, but apparently this RGB 656 pretty much represent what you are able to see with human eyes. So having more detail makes little or no sense. At least on a display this size, you cannot see the difference. So you can pretty much represent all colors. Then you can see there is some register definition. Go back and watch my video on I2C or SPI. Typically the way these works is that you write to a specific register, and in this case you can see we have all these registers. If you are really interested in what they do, go back and read the data sheet. It is 300 or 400 pages long, so there's quite a lot of reading if you really want to understand. 317 pages is quite a lot to read if you really want to understand what you can do with these displays. And there is some other stuff. Down here we have the public functions, and you can see that there is an init, there is a set rotation, there's a fill color where you can fill the whole display with some color. And in fact, before we do anything else, let's try to use that. So STM32 fill color, copy that, and we go over here, and I don't want to do the test right now. So let's try to run this ST fill color, and let's fill it with yellow. Remember, that was defined in the header file. Let's show here. Let's show this. I can show you here what I have. No, there. So I have one of these devices, and it is connected to one of my Jolt Connect programmers, so I can program and debug it there. And you can see right now it's showing some red stuff. But if we go back there and just try to fill the display with yellow, let's try to run that. There we go, and it flashes, and it... I hope this actually shows. It didn't. Oh, there we go. I don't know what happened. So that should be yellow. It's very hard to record LEDs with a proper color, so sorry if it looked, but I take my word for it. It is yellow. We could try to change this to red and run again and hope it works this time. There is some issues with the reset. Doesn't seem to work first time. There, it became red. I think what is happening is actually we need to make a small delay, L delay, 50. I think that will work. There's something about after you initialize that ST7789, it needs a delay before you start writing to it. That did not change anything. It seems to work every second time. I'll have to look into that, but it's probably not going to be in this video. Just for the last one, let's try green. And we probably have to do this twice again. I don't know why. Let's try to make it green. Yes, it didn't work first time. There it came out at green. So let's go back and look at the a little more into the code. Now there is, I'll get back to that. So let's look at what else we have. Well, first of all, we got a draw pixel command where we can set a pixel at any color on this display. We can also fill an area, so we can have a start point and a width and a start Y and the height, and then fill that with certain color. We can draw big pixels, so they are white pixels. I don't know what the first fill should pretty much be doing the same. We can also draw lines, we can draw rectangles, we can draw circles, we can draw an image, so we can put image data into it, and we can invert colors. We can write characters using a certain fonts. There is a number of fonts defined in the font library. Then you can draw filled rectangles, filled triangles, and filled circles. And most importantly down here, or not most importantly, but there is a function called ST77_test. Now let's, for fun, look at that function. It is down at the end of the source code here. And you see it simply cycles through. First it fills with different colors, then it writes a string, and so it basically goes through all the functions in the library and show you how to use these functions. So let's try to run that test actually. And so if we go back to my main source code here and remove that and say, well, I want to run that test. It takes quite a long time to run it, but let's try to run that. But let's see if that works. This is amazing. I need to figure out what's happening here. It works every second time. I try to run it again, but this time I will actually show you the device there. And we try to run again. And there it comes, and you can see it started out. It toggles to the different colors. Then it'll write some stuff. It is a little bit hard to read. But these are the filled triangle and the not filled triangle, and it ends with a filled triangle. So that is pretty much all there is to it using this library. Now, if we go in and look at what is actually happening in this library, this one is essentially the meat of this is up here in the. You have a command, say write command, and you select, you toggle that DC data command, and then you transmit the command to the device, and then you unselect it again. If you write data, you select the device, you set the data command. Up here we were clearing it, and then depending on whether we use DMA or not DMA, we either use SPI transmit DMA, or we use just SPI transmit. The library can work with DMA or without DMA. It's a bit quicker if you use DMA, but it's not that different. It transfers the data quicker, because you can see here, if we are using DMA, we will send it with DMA, but we are still waiting until the ST7789 SPI port is ready to receive more data. But if it's a big area you want to fill, rather than doing a pixel at the time, it is faster to send the SPI in one chunk than it is to send in a video. But we still have a write small data where we don't bother with the DMA because it's not worth it. But these are the only functions, these three functions up here, that actually uses the hardware to transmit data to the display. The rest of the function in this library is simply writing commands into these various and transferring the data, various registers, and transferring the data in one way or another. So we see the rotation. It is simply a command into a register, and we use this write small data for all of those. It's just 8-bit that is being written into a register. We can see we set address window. The initialize, you can see here how you actually initialize this display, and it is simply a matter a bunch of values. We set this gate control, VCOM settings. I have no idea what most of them doing. Read the datasheet if you are really interested in this. But it is simply a matter of writing this data. Here, how we do a fill. A certain color, we set an address window, and we just boom. And then if we use DMA, we simply build a buffer and send it out per we have a frame buffer defined how big. It's not the full display, that would be take too much memory, but draw pixel, they all follow the same format. So have a look at the code if you are really interested in the inner workings of this. In short, it is actually quite easy to work with this display. I am probably going to make a follow-up video to this, where I'm going to actually write something useful on the display to show. I might combine it with USB HID to make a little display that you can human interface device. I don't know. I don't really plan that far ahead. It depends on what mood I'm in, what I'm going to do. So I think this is all I'm going to talk about in this video. ST7789, really cool little displays that can be used for a number of things. And if you look at AliExpress, and I'm sure eBay as well. In fact, let's try eBay. And the easiest to search for is probably simply search for ST7789. And there, come up. This was a 2.4 inch, so quite big one. Here are the smaller ones, the 1.3 is there. So yeah, they are a little more expensive from here than it is from AliExpress, but that is probably because of Trump's tariffs. I don't know. But they are both $13. That's insane. But yeah, I mean, they are readily available in different formats. So what you can do quite easily, if you don't want to design your own PCB for this, you can simply have screw holes, so you can mount this on a front panel and just make a cutout for the display. It is entirely possible to use these in projects, and they are quite stable. They don't use much power. It's essentially just the backlight. The LED backlight is all that is using. So you can make some really cool clocks and stuff. In fact, the first thing I programmed on this was actually a clock, but I think that was from an Arduino or something like that, or an ESP32, or I don't remember. So anyway, that's all I want to say about this in this video. Please do like and subscribe down below. It is absolutely essential. And as usual, have a wonderful rest of the day.